Hey there. So, you're gearing up for a practical exam in automation, huh? Well, you are in exactly the right place. Today, we're going to break down one of the most fundamental skills you need to know, wiring up PLC inputs. Trust me, if you can nail this, you're on your way to mastering any control system. Let's get right into it.
Here's the game plan for today. We're going to start with the absolute basics. What even is a PLC input? Then we'll build up from there, starting with the simplest two-wire connections, moving on to powered three-wire sensors, and then finishing with the more complex four-wire setups. We'll wrap it all up with a super quick review that's designed to lock all this in your brain for exam day.
All right, let's start at square one. The absolute best way to think about this is with a simple analogy. If a PLC is the brain of a machine, then its inputs, well, those are its senses. They're the eyes, the ears, the sense of touch. They're what tell the brain what's actually going on out in the real world.
So what is a PLC? It's basically a super tough computer built to survive the heat, dust, and vibrations of a factory floor. Its entire job is to read the program you've written, look at the information coming in from its inputs, and then make decisions to control stuff like motors, lights, or valves.
And this right here, this is the core idea. Without inputs from things like sensors and switches, a PLC is completely blind. It has zero information, no context. It's just a brain in a box, totally useless, because it has no idea what's happening around it.
Now, the information coming into that brain can take a few different shapes. You've got discrete signals, which are super simple, just on or off, like a basic light switch. Then you have digital signals, which are really just a fancy sequence of those on-off states. And finally, you've got analog signals, which can be any value in a range. Think of a dimmer switch, not just on or off, but all the levels of brightness in between. Okay, let's get into our first wiring type. And we're starting with the most straightforward of them all, the two-wire connection. You can just think of a standard light switch on your wall. It works on the exact same simple principle.
At its heart, a two-wire device is all about one thing: creating or breaking a single electrical path. It's giving the PLC a very simple binary answer. Is the button being pushed? Is the lid closed? Is the part in position? The PLC just gets a clear yes or no. That's it.
The wiring itself, it's about as simple as it gets. One wire goes from the switch to a specific input terminal on your PLC. The other wire goes to your common terminal. The switch or button just physically connects or disconnects that path. It really doesn't get more fundamental than that.
And you see these things everywhere in the real world. That big red emergency stop button you see on every machine? Classic two-wire device. Simple limit switches that get physically bumped when a machine part moves into place, or basic push buttons. They're all just simple, unpowered switches completing a circuit.
Okay, so two-wire is great for passive devices that don't need their own power. But what happens when the sense itself needs to be active? When the sensor needs to do some thinking on its own? Well, that brings us to the next level of complexity, the three-wire connection.
And this is the critical question, right? A simple mechanical switch, it doesn't need electricity to be a switch. But an electronic sensor, like a proximity sensor that can detect metal without even touching it, it does. It has tiny little circuits inside that have to be powered up to work.
And that's the fundamental difference. Two of the wires are just for powering the sensor itself. You'll have a positive and a negative. The third wire, that's the one that actually sends the on or off signal back to the PLC's input.
Okay, now lean in for this one, because you absolutely have to know this for your exam. It's the concept of sourcing and sinking. This is all about the direction the current flows. In a sourcing, or PNP setup, the sensor sources, or provides, a positive voltage to the PLC input when it turns on. For a sinking, or NPN setup, it's the opposite. The sensor sinks the current from the PLC input down to the common or ground. The key takeaway? You have to match your sensor type to your PLC input type. If you have a PNP sensor, you need a sourcing input. Get it wrong, and it just won't work. It's a critical detail.
These sensors are the real workhorses of modern automation. Proximity sensors that can detect metal, photoelectric sensors that use a beam of light to see an object, capacitive sensors that can even detect liquids or powders. They are all pretty much always three-wire devices that need their own power to operate. So, we've covered simple on-off and powered on-off. Now it's time to move to our final type, four-wire connections. These are for devices that need to communicate a bit more than just a simple I'm on or I'm off. That extra fourth wire gives us way more options. Instead of just a simple yes or no signal, a four-wire device might need to send a variable signal,
like an exact pressure reading, or it might even have multiple separate signal outputs for different conditions.
So here's how it usually breaks down. 2 of the wires are pretty much always for power, your plus and minus. The other 2 are for the signum. This could be for a variable analog signal, like the very common 4 to 20 milliamp signal, which can represent a whole range of values. Or it could be for 2 separate digital signals. For instance, one for a normally open contact and another for a normally closed contact, which is great for safety and redundancy.
You're going to run into these with the more advanced sensors. A pressure transducer that gives you a precise PSI reading, not just high or low. An ultrasonic sensor that measures the exact level in a tank. A temperature transmitter. All of these need that 4-wire connection to both power the device and send back that rich analog data. Okay, I know, we've covered a ton of ground, so let's bring it all together right now. This next part is your study guide. This is the key information you need to walk into that practical exam feeling totally confident.
This table right here, this is your golden ticket. Go ahead, pause the explainer, take a screenshot, do whatever you need to do to burn this into your memory. This is your cheat sheet. Let's run through it. 2 wires for a simple unpowered switch. 3 wires for a powered sensor, and you must match the sourcing or syncing type. And 4 wires for powered sensors that are sending back more than just an on-off signal, like an analog value. Got it?
You know, this quote really gets to the heart of what makes PLCs so powerful. Their flexibility. The magic is in the software. But, and this is the big but, that magic can't happen if the PLC isn't physically wired correctly to its sensors in the first place. The physical connection is the foundation for absolutely everything else.
And that's really what this all boils down to. When you understand how to correctly connect these different devices, you're giving the PLC the ability to see, to feel, to sense, and to react to its environment. You are putting the control in programmable logic controller.
So, let's end with a practical thought experiment. Imagine a safety gate on a machine. You don't just need to know if the gate is closed, you also need to know for a fact that it's securely latched shut. Based on everything we've just covered, which wiring setup would give you the most reliable information? Give it some thought. Thanks so much for joining me, and seriously, good luck on that exam. You've got this.